I am going to solve a question from TIFR 2024, and in this question a surface is given and we have to calculate a vector which is parallel parallel to that surface. So options are already given. Okay, so suppose this is that surface and this is that point. The point is 1 2 3, and we can calculate a vector which is perpendicular to this by gradient. You know, grad of this surface will give you a vector which is perpendicular to this surface. And if I take dot product with the vector which is tangential, it should come out to be 0, because two perpendicular vectors, dot product is 0. So the first step is, let us calculate the gradient for this surface. So grad of 2x cube z plus 4y square z plus 3z square minus 81. Let us calculate this gradient. So I cap del by del x of this, so it will give me 6x z, and here there is no x gone, plus j cap del by del y. So del by del y, this is 0, this is 0, this is 0, only this will survive. 8yz plus k cap, so del by del z, so it will be 6, here it is 6 square z, and now 6, so now del by del z is, just a second, del by del z is 2x cube plus 4y square plus 6z. This is del by del z. Okay, now put the values 1 2 3, so it will become I cap. If I put here 1 and 3, it will become 18 plus j cap 8yz. Yz means 3 2 6 and 8, 48 plus k cap 1 2 3, so it will become 2 plus here 2 2 4 4 16 plus 6 into 3 18. So this will become 18 I cap plus 48 j cap plus 36 k cap. Okay, now we have to see, this is this vector. Okay, so if I write this along this a vector n1, so this is n1 vector which is perpendicular, and let us call this as n2, which is among these options. So if I take n1 dot n2, it should be 0. So let us check from option 1. 18 to 36 minus 8 3 24 2 4 3 at 12 13 14 and plus 6 3 18 1 3 3 9 1 10. Okay, and this becomes 0. So that means option A is the tangential at this point 1, 2, 3 on this surface. So this is the method to use the gradient to get either a normal vector or a tangential vector. Thank you.